As you have been running your programs, you have seen Python crash when your code had an error. This can be caused by typos you've made, or by calculations that Python could not complete, such as dividing by 0, taking the square root of a negative number, or trying to convert input to a number when the user entered non-numeric characters. Python has a feature known as exception handling to allow you to catch errors and handle them more gracefully than crashing. Exception handling will not allow you to catch syntax errors, but can handle the other errors mentioned. We'll look at a couple examples of that in this video. We'll run this program and enter 5.5. We see that it crashed on the input line because it cannot convert the string 5.5 to an int. Note you can convert a float 5.5 to an int, and it will truncate it to be the integer 5, but Python will not let you convert a string that is not an int directly to an int. If we want to catch this with exception handling, we need to make note of the Python error that occurred. In this case, it is a value error. Let's run it again and enter 0, and we see that it crashed when we try to divide by 0. The Python error that occurred is a 0 division error. Now we'll look at how to use exception handling to prevent the code from crashing. We have two new Python keywords, try and except. The syntax is use the keyword try and a colon. Since the line ends with a colon, the next line must be indented. Now we put the statements that we want to try to execute. Next we put the keyword except in the error we want to catch, followed by a colon. Note this is indented at the same level as the try statement. The semantics of this is that the code indented underneath the try statement is executed. If it works correctly, the except statements are skipped, and it would continue on line 7 in this case. If a value error occurs while executing the statements indented underneath the try statement, Python executes the except statements. So in this case, if we do not enter an integer, it will print out the message and assign n to be 0. If an error other than a value error was produced, the program would still crash since we only caught the value error. This next example shows that you can put multiple statements underneath a try clause. It will attempt to execute them one after another, as Python normally does. If an exception occurs while executing either one, it stops and checks if we have an except clause for the error that was generated. So in this case, if n is 0, it does not execute the statement to print x, since the error occurs on the previous line. Instead, it will execute the statement on line 11 underneath the except clause. If an error occurs during the division, the variable x will not have a value. Even if x already did have a value from an earlier assignment statement, we don't want to print it if the error occurs. That is why we place the print statement in the try clause, even though that statement will not produce a 0 division error. The last example shows that you can catch multiple different exceptions with multiple except clauses for one try clause. We could put all the code we want to execute underneath the try clause, and then use different except clauses to catch each possible error. If we get a value error, we know that we failed to convert n to an int, so we can print out that error message. If we get a 0 division error, we know that the division expression failed because n was 0. This example also shows that you can catch any error by using an except statement without a specific error after it. This is generally discouraged, as it means you don't know what went wrong, so you probably don't know how to handle it correctly. But in this case, we are just telling the user something else went wrong. Let's run this and enter 0 for the integer. We'll see the first except statements are not executed, as we did enter a number, but the second except statements are executed because we cannot divide by 0. For the second input, we'll enter a non-numeric value and see that it printed the statements for the value error except clause. This program shows us how to use exception handling rather than if-else statements to handle the possibility of taking the square root of a negative number. If we get a value error while executing any of the code indented underneath the try clause, it will print there are no real roots. There are other errors we could encounter, such as the user entering non-numeric values for the coefficients. That would also produce a value error. Let's run it and enter a non-numeric value for a. We see that it immediately prints no real roots, rather than asking us to enter the other coefficients. This is because the first input statement generated a value error when we entered a non-numeric value for a. This version shows how we can determine which type of value error occurred. I'm going to use the Python console to see exactly what happens when we take the square root of a negative number. In addition to value error, it says math domain error. So now we can use this variation on the except clause to get that additional information. Note that as is a Python keyword. We can convert that object to a string, and we will get the string we saw from the console when we try to take the square root of a negative number. This will allow us to distinguish between a value error when the user didn't enter numeric values and a value error when we attempt to take the square root of a negative number. We can use an if-else statement to print out the correct error message. We'll run it and enter a non-numeric value for b and see the invalid coefficient message. When we run it and enter 111, we see the message about no real roots. As we've seen, we could catch the discriminant being negative with either an if statement or exception handling. In that case, it's a personal preference for which one to use. We can only catch the invalid input error using exception handling, as it crashes as soon as you enter a non-numeric value. There's no opportunity to use an if statement after the input statement to check that.